Hello friends, myself Gitika Aswani, an assistant professor in Department of Electrical and Electronics Engineering in ABES Engineering College, Ghaziabad. So today we will going to discuss one topic or from Unit 1 from the subject Electrical Measurement and Instrumentation. Our very first topic is the Introduction to Measurement System. So what is the measurement system? Measurement of a given quantity is a result of comparison between the quantity whose magnitude is unknown and predetermined or predefined standards. So two quantities which are being compared and result is compared with its numerical value. Measurement is the science of determining values of physical variable. So in the layman terms, we can say that measurement is to compare the result with the standard value or with some standard value. For example, measurement of the length, like when we go to the tailor and get the fabric got stitched as per our body measurement. So the tailor firstly have the device in his hand is the inch tape. Through the inch tape, he firstly measures the take the body measurements, and accordingly he will stitch the cloth. So this is as per our desire, as per our fitting, we get the clothes. Similarly, if we want to measure the temperature, body temperature, then we need a device as thermometer, and through which we can do the measurement. And this digital type thermometer is having the display which is going to measuring the body temperature. And that display and the value is being displayed there along with some standard unit. So the unit used for this is in degree Celsius, Fahrenheit, Kelvin. So that is used for the measurement of temperature. Similarly, length measurement is done in terms of meter. So this is in terms of the whatever the numerical value is being written there and the standard unit, right? So this is what I was saying. The measurement of a given quantity is a result of comparison between the quantity whose magnitude is unknown and predetermined or predefined standard, right? So standard is the measurement unit and the numerical value which is unknown, which is being measured with the help of that device, correct? Now next is physical quantity. A physical property that can be described by a number is called physical quantity. For example, like mass of a person is being measured in terms of its numerical value and the standard here. The standard for the unit for the measurement. So that is in kg. So it is being taken through the weighing machine, right? Then length of a bar, 3 meters, which is being measured with the help of the inch tape. Temperature of a room measured by the temperature sensor. That is 25 degrees Celsius. So various types of physical quantity which are being used, different types of physical quantity. So one is your fundamental quantity, the quantity which do not depend on any other physical quantity for their measurement is known as fundamental quantity, like mass, time, length, and temperature. And the derived quantities are one which are being depending on the fundamental quantity for the measurement. That is known as the derived quantity. So example क्या है इसके? Examples है area, speed, volume, force. So the derivation which we get, the formula which we will be getting, it is again depending on the fundamental quantity. Like the area is being measured in meters square, centimeters square, speed is being measured, then with some unit, then volume is being measured, then force is being measured with some unit. So that unit force is being measured in Newton, right? So that unit is again being derived with the some formula. Then volume in meter cube. So again, it having some formula. But again, the unit or the formula is again depending on the fundamental quantity, right? So the standard used for the measurement of physical quantity is called a unit. The standard which is being used is the unit. For example, meter, foot, inch, or for a length, and kilogram pound for mass, Fahrenheit, Kelvin or for temperature. So this is all we have discussed earlier, that this is the standard units which is being used for the measurement of length, for the measurement of mass, for the measurement of temperature. Now, let's see the generalized measurement system. The measurement system is being divided into different, represented as with the different block diagrams, where different components is being used for the measurement. And this whole generalized measurement system can be implemented on one or the other application which is being used in the real time for the measurement purpose, right? So let's see if any physical quantity we need to measure, like if we want to measure the temperature or measure the pressure or measure the air flow rate or measure the viscosity of some liquid or measuring the force. So all those quantities which is required to be measured is known as the physical quantity. And this it is being done with the help of the primary sensing unit, which consists of the sensor. And sensor is basically converting the physical quantity to the mechanical quantity. This mechanical quantity is further passed to this transducer, which is converting it into the electrical quantity. That electrical quantity is further being passed to the variable conversion element or variable manipulation element. So this is combinedly known as the signal conditioning unit. What does it do? It converts whatever the signal we are getting here in millivolt or milliampere at this stage through the sensing element, which consists of the sensing plus transducer unit. So whatever be the element, whatever be the millivolt or milliampere voltage or current value which we are getting here, then we need to boost that voltage value, right? So for boosting, we need some amplification signal, amplifier, which amplifies that signal so to the desired value, so that signal can be transmitted in a healthy way to the other end or to the control station, right? So if there is also a signal conditioning unit, also consists of the filter unit, filter circuits, which filter out the noise or any harmonic or unwanted signal which disrupting the main signal or our signal, so that signal can be filtered out or the unwanted signal can be filtered out from there. Then it also consists of the A to D converter, which converts the analog to digital value, because further we need to transmit it or to see the signal at the digital end at the control station in the console room to the systems. So for that, we need the signal in terms of the digital value. So this variable conversion element and variable manipulation element is combinedly a signal conditioning unit. This amplified signal is further transmitted to the data transmission element. Through the transmitter and through the cables, it is being sent to the control station, right? At the control station, the signal is being received in the computers, and in the computers at the in the software like LabVIEW, we can analyze those signals there, right? And then we can further see the do the analysis there with in terms of the waveform, in terms of the pictorial representation, and then the data can be presented in terms of the report form. Need to analyze and to check the how the system can operate in defensive manner during any contingency, so it can be easily readable to the operator. So all those things can be done easily. So while sitting in the control station, through seeing the data on the screen, we can take the corrective measures at the time of the contingency. So this is the main aim for that generalized measurement system, that so many things is being used in between. And further, the analysis can be done with the help of the observer or the operator there or the technical staff there, and then corrective measures can be done and the improvement can be further taken, right? So this is the example of the generalized measurement system. So generalized measurement system, again, we can see it is described the stage wise, like physical quantities first sensed and detected and then converted into electrical signal using sensor transducer unit. Then variable conversion element is used to convert the output to some other desirable form, like A to D converter can use for converting the analog output to digital. Variable manipulation element manipulates the given signal to original form, like electronic amplifier, which accepts the low voltage signal and produces the voltage of higher magnitude. Now, data transmission element, data transmitted to the control center. Like, for example, spacecrafts are physically separated from Earth, where control station guiding their movements. So for that, they keep on need the data, right? And get connected with that, the spacecraft, which is physically apart, but they are in the region where the signal transmitted and at the Earth station, the signal can be received and the further communication can be done. Data presentation element, the information about quantity under measurement has to be conveyed to system for monitoring, control, or analysis purpose. So for telemetry system, this generalized measurement system is very helpful. And for many application, real-time application, it can be used. Now, next comes instrument and measurement system. So measurement involves the use of instrument as physical means of determining quantities. Like instrument enable us to determine the value of unknown quantity which human eye cannot measure. So human eye cannot measure those quantity, like speed measurement of DC motor that we generally do in our laboratories, electrical labs. So speed measurement for DC motor can be done with the help of the tachometer. So through the tachometer, we can see that what would be the speed of this motor, at which speed this motor is running. So it can be easily measured with the help of the tachometer that it is running at 1500 RPM, right? So instrument enable us to determine that. It measures the value of that unknown quantity and with the standard, with its standard value, with the predefined standard, right? And instrumentation is a device used in the measurement system. So again, in the generalized measurement system, various instruments used, and those instruments collectively used in the measurement system for the measurement of some real-time application. So next comes your types of instrument used in the measurement system. What are the various types of instrument that can be used in the measurement system? So electronic instruments used. They are more reliable as improvement in design and manufacturing process of semiconductor devices. They are light, compact, and power consumption is low. They have fast time responses. So generally we go for DSO just to analyze the waveform of voltage, current, and to measure the phase shifting, and to measure the frequency, time period, duty cycle. So all that things can be easily done with the help of the DSO. In the pictorial representation, in the waveform analysis, we can do that. Then next type of instrument is mechanical instruments. They are also very reliable for stable condition, and at times they are unable to respond rapidly during the dynamic and transient condition because they are bulky. And electrical instruments are also having the limited time response. So one or two example of mechanical instruments here for measuring the pressure. There is the pressure gauge, and the other is for the measurement of the temperature. We can use this scale for their indicating scale, which is measuring its temperature. And in the similar manner, we can have the ammeters, voltmeters in our lab, which can be used as the deflection type devices. And they can be used for the measurement of current, voltage, wattmeter for the power measurement used in the laboratories, right? Now, classification of instrument we will see. So under the classification, we can go firstly for the absolute and secondary type instruments. So what are absolute instruments? These instruments give the magnitude of quantity under measurement in terms of some physical constant of the instrument, like tangent galvanometer. So what does it do? It generally used for the comparison as a standard instrument, which is kept in the national laboratories, and it works with the absolute instruments for routine work. And generally it takes a lot of time for while taking the measurements. So generally we don't use in our labs because they are very uh, expensive also, and it takes a lot of time for taking the measurements for routine work. So in generally we go for the secondary type instruments when we want to demonstrate the students from how the current is being measured through the ammeter, how the voltage is being measured through the voltmeter. So in that case, we go for the secondary instruments. They are at the cheaper rates and easily available at the manufacturer ends, different manufacturing ends, and different manufacturers who design these ammeters, voltmeters, wattmeters. So they refer some standard instrument for the calibration, and might be the tangent galvanometers and other types of absolute instrument can be used by them. So these instruments, secondary instruments, are used so constructed that the quantity being measured can only measured by observing the output indicated by instrument. For example, voltmeter, ammeter. So these instruments are used in the labs for taking the measurements, generally calibrated with the help of the absolute instruments. So absolute instruments are generally used in the national laboratories, and secondary instruments are generally used in the lab for routine work. Other classification is on deflection and null type instruments. So measured the quantity produces some physical effects which deflects or produces a mechanical displacement of moving system of instrument, and the opposing effect is related to deflection, which can be directly observed, and the balance is achieved when opposing effect equal to cause producing the deflection. For example, PMMC, MI type, ammeter, voltmeter can be used for that purpose as the deflection type instrument. Now, null type instruments, null type again, where the zero leads to the determination of magnitude of the measured quantity, like we go for the Wheatstone bridge and potentiometer. So detector which detects null condition when the effect produced by measuring quantity is equal to the effect produced by the opposing quantity. So accuracy of null type instrument is higher than the deflecting type instruments. So in today's video, we discussed about the firstly what is the measurement system, and what are the different quantity, what is the physical quantity, what do you understand by physical quantity, types of physical quantity, that is fundamental and derived quantity. And then we further discussed about the generalized measurement system, that in generalized measurement system it collectively consists of the various instruments used for the measurement system for a specific application. And then we discussed about the classification of the instruments, absolute and secondary instrument, then deflection and null type instruments, and various types of measuring instruments used in the laboratories like electrical, mechanical, and electronic instruments. And what are the limitation of the electrical instruments? What is the limitation of mechanical instrument? And what is the advantage of the electronic instruments used in the laboratories? So this all we have seen in today's video in these slides, and I hope this is understandable by everyone, that how the measurement system works and how the different instruments play a role for measuring the quantities for a specific application. Thank you.